Hello everyone, we're using the Jupyter Notebook to predict the power output of power plant in our data sets. So we'll be installing the pandas, NumPy, and we'll be using two algorithms from our machine learning algorithms from scikit-learn. That will be the linear regressor and the key neighbors regressor. And for the metrics, we'll be using the two metrics for the evaluation. The one will be the mean square error and another will be the R2 score. Alright, let's run this. And I don't need to update the scikit-learn because I already have the updated one, so I'm gonna skip it. And the matplotlib inline, this will help you to look your graph nicer in the notebook. So we're going to load the datasets that's given in our assignment. And then let's see what's inside the datasets. There are a total of 5 columns there, and the PE columns, that's our targeted label, and the rest are the features. So that we'll be using these features to predict the output of the power plant. Okay, so let's see some little more about our data. And there's almost 9,500 rows, so we're going to split them into the test and the train set. The test set will have the 80% of the data, and the train set will have the 20% of the data here. Alright, so we are going to use the train test split that is provided by the scikit-learn here that you can see up there. And we're going to split them and test in the train. Alright, cool. And then we're going to use we're going to use the two metrics up here. One of our evaluation metrics will be mean square error, and another will be the R2 score. For the information that you could see, these are the metrics that you could use in this sklearn, so I just printed out just for the information. The first one will be the simple linear regressor model. So we are going to use the cross validation while we are building the linear regressor. Okay, so we're going to use the 5-fold cross validation. So basically, it will split into the 5 data sets, and then it will be a partitionally test set validation cells while it's doing the 5-fold. All right, let's go. Okay, and then we have basically, since we are splitting the test data train data sets into the five subsets, so that will give you the five of the 5 metrics for each of the metrics, one for R2 and one for the MSE. So here is please note that it's a negative MSE because that's what sklearn provide you, but basically it is just the MSE with the negative sign. That's all. All right, cool. So that's our average R2 score and the MSE mean square error from our linear model. All right, so once we get this information, so we are going to actually train our test data, and we're going to test with our test data sets here. All right. Okay, so you see that we got the R2 score on test data sets, and our MSE score on here, and they are not much that difference from the our average of our validated training data sets here. Even it's slightly better here. Cool. Now we're moving to our k neighbors regressor model. Okay, so basically, nearest neighbor is the regressor. Is like it's a regression model, but it's you have to provide the you have to search what would be the optimal neighbor for the what will be the up or the best clusters set that could design for your algorithm and provide you with the most relevant prediction. So here I don't know what's the number, so I'm going to give the number from k number from 1 to 20, and then we are going to print it out in the chart and see that what would be the best k number for our model with the k neighbor regressor. All right, so here we are plotting out the mean square error. So you can see that it's at the k number 6, you get the lowest mean square error. MSE is the lower the better. So I would say we're going to pick up k here, and also another for the R2 score, we are going to plot it out. And again, you'll see that the R2 score is highest around the 6. So we are very certain that 6 is the best k value for our model here. All right, so we are going to fit in our data with train data sets with a k value 6, and we're going to predict with our test data sets. Cool, let's do this. All right, and I'm going to print out the model R2 score and the MSE. So you see that here our R2 score is 0.945, so basically it's 0.95, that, and our MSE is 14.47. So the k neighbors model, regressor model, has the better R2 score and the lower MSE, so than the simple linear regressor model. So that's mean it has the better performance in this exercise in predicting energy output of these power plants. Well, that's pretty much. Thanks for watching.